Hello, everyone, and welcome back once again to our next lesson. I'm really excited about this one because today we're going to be dipping our toes into the mysterious and fascinating area of computer programming. Now, believe me, I understand that that term itself strikes fear into the hearts of many people who have never done it before. But I want to assure you that it is not necessarily as complicated as most people assume it to be. Computer programming is simply defined as the act of providing instructions that a computer can follow in order to make stuff happen. That's it. We're going to make stuff happen. Now, there are various levels of complexity in what are known as programming languages. I'll give you an example. When you want a computer to do something, essentially you are sending instructions to the microprocessor, the CPU in the computer. And that CPU does not understand English. It doesn't understand very much at all, but it does understand ones and zeros. And those are called bits. A 0 or a 1. Those are the only two possible values that a microprocessor can process. By the way, at that level, there is a name for that type of computer language. It's called machine language. Now, let's imagine that we were to print out a complicated computer program in machine language, and it was on thousands and thousands and thousands of sheets of paper. A human being would look at that, and literally they would just see digits. They would simply see binary digits called bits. By the way, that's where the term bit comes from. A bit is a contraction of the term binary digit. So a bit is the smallest unit of information in binary, and it is either an individual 0 or an individual 1. So if you took that several thousand page transcription of zeros and ones and look at it, it would be next to impossible for you and for most humans to just take a glance at it and read it in a way that you would understand how the microprocessor of the computer is using it and what those instructions are. What are we trying to get the computer to do? So instead of writing our programs in machine language itself, programmers use what are known as abstractions. And abstractions refer to human-readable programming languages. And by the way, it's not important at all if you know anything about programming languages or how they work or anything like that yet. But I bet you've probably heard of at least a few of them, such as Java, C++, or maybe even Python. Unreal Engine is compatible with many different types of computer languages. It even has one of its very own, which is called Verse. Now, there's one I bet you haven't heard of. But beyond that, it also has something very special that gives certain people access to being able to program very robust systems to make things happen inside of Unreal, even if you have never studied programming, even if you have never written one single line of what they call code in your life. All computer programming languages are abstractions, higher levels of abstractions, of machine language. Remember, machine language is generally not readable by a person. Now, if you were to look at a printout of C++, for example, you probably still wouldn't understand that. However, if you had training in that computer language, you might be able to look at that and understand what is happening. However, you just don't happen to know that language. And C++, as well as most mainstream programming languages, are in the form of textual syntax, meaning that you will create those computer programs by sitting in front of a terminal with a computer keyboard and typing out line after line of, letters and special characters in a certain format. And if you're not familiar with the structure, you're going to look at that and it's going to be just as perplexing as anything else. But there's more than one way to skin a cat, because inside of Unreal Engine, we have yet another very special type of programming language. And it happens to be called Blueprint Visual Scripting. Blueprint Visual Scripting is visual. you do not have to type one line of code whatsoever. And once we start creating systems using Blueprint visual scripting, I think most people will take to it, at least initially, much more easily than syntax-based programming. Yes, Blueprint is an abstraction, and it is indeed a higher level of abstraction compared to C++. However, it is still based on the same mainstream concepts. Therefore, I feel confident in making the statement that by learning how to program in Blueprint, that will give you insights into how many programming languages work, whether you know their syntax or not. Blueprint is actually based on C++, as we will find out throughout the remainder of this course. So here is going to be our first example of a blueprint. And I have a folder. I should have a folder. I guess I don't. So I'm going to create a folder called Blueprints. New folder. And let me just scroll down so that you can see it here. And we're going to call that Blueprints. And we can organize this folder any way we want with subfolders. So let's open this up, and I'm going to make a subfolder called Demo Blueprint. Helps if we type it correctly. Demo Blueprint. Okay. And I'll then open that up. And it's empty. There's nothing inside. Now, blueprints belong to a group, or sometimes this is referred to as a paradigm, of programming languages that have certain things in common. And this would be inclusive of languages such as C++. They are known as object-oriented programming languages. And things in your world, whether it has functionality or not, is an object. Now, if it's literally placed inside your game world, we can also refer to it as an actor in that sense. But from a computer programming point of view, it is an object. And the definition of an object is an instance of what's called a class. Now, in object-oriented programming, the term class sounds like it has some terrifically impossible to understand meaning, but in fact, it probably means exactly what you'd expect it to mean. Different objects in real life differ from each other. For example, there are plants and there are animals, right? You could say there is a class called plants and there's a class called animals. However, that's not sufficient to describe the diversity of life forms that exist on Earth. So maybe in the class that's called plants, for example, you can create what we call child classes. The child classes from plants could be things like trees, or vegetables, or flowers, or grass, or any other way that I might need to categorize different types of plants. If I have trees, for example, as a class, that is a child of the parent class that's called plants. So I've got this child class called trees, but now we know that there are different kinds of trees. There are evergreen trees, there are palm trees, there are willow trees, there are oak trees. Each one of those could be a child class. And furthermore, certain trees bear fruit. So I can have trees that bear fruit and trees that don't. So let's suppose that I have a child class called fruit-bearing trees. Even those can have child classes because not all fruit-bearing trees bear the same types of fruits. The same thing is true for the animal class. Well, an animal is not a plant, we know that. That's just a way of keeping things categorized, organized into separate relevant categories. But in the animal class, imagine the diversity of animals that exist on planet Earth. There are bipeds, for example, and bipeds are animals like people and certain great apes. They walk on 2 feet. There are insects, there are fish, there are marsupials, there are amphibians, and there are many subclassifications within those. So we are going to be working primarily with instances of classes and then implementing their functionality using the computer language or visual scripting language known as Blueprint. So let's make our very first blueprint right now. To do so, I'm inside my Demo Blueprint folder, and I'm going to right-click, and I have to choose a Blueprint class. Now, when I click this, I'll be presented with a list of typical types of parent classes. Any of these base classes can have child classes that describe an entity or an object with greater and greater degrees of specificity. But the base class that everything else inherits from is called the actor class. So let's just make an actor class right now, and we have to give it a name. The naming convention for blueprints are BP underscore, so that's capital BP underscore, and then something that is a sensible name for it. So I'll type my test actor. My test actor. Okay. Now, if I open this up by double-clicking it, what you're going to see is the user interface in which we are going to be doing our blueprint programming. And I will let you see what that looks like now. Again, I'm going to use my left mouse button and double-click on this icon here. Double-click. When I'm working inside of a blueprint, it is helpful to take the tab and dock it. And by the way, this is not a blueprint. I probably shouldn't have some of these other things open for now. This is a blueprint. And by the way, what you're looking at right now is what blueprint scripting looks like. It's not lines of code. It's nodes. That's what these are called, nodes. And all these different nodes have specific functionality. And the way that we wire them together follows the same logical patterns and the same logical requirements as any other branch of mainstream object-oriented programming. So let me just close this one. And here we are in an empty blueprint class, the one that we just made. And I'll remind you, it still sits here in that folder, Demo Blueprint My Test Actor. I double-clicked it and I docked it here, and we don't see much of anything. This icon here just represents the default scene root, and it is not visible while you play the game. Okay, so every blueprint class has a default scene root, and among other things, the default scene root is what determines where something can be located if you place that actor in a specific spot within your game world or environment. Now, most of our actual programming is going to take place here in this tab. Typically, when you make a new blueprint, there's going to be 3 tabs. One of them is called the viewport. One of them is called the construction script. And then there's this one called the event graph. And the event graph is by far where you're going to be spending the majority of your time when you get into blueprint scripting. Now, blueprint scripting largely is based on a concept known as events. And it gives you as a courtesy, most blueprints will give you as a courtesy 3 basic event types just to get you started. One of them is called Event Begin Play. So what will happen if you make use of Event Begin Play is that this node will fire what's called an execution pulse out of that. It looks like a baseball diamond, okay? That little symbol right there. So that's an execution pin, and that will just output, you can think of it as sort of like a pulse, do something. And Event Begin Play simply fires anytime you press the play button and the game begins. So let's do something right here, right now. We're going to write our very first computer program making use of the Event Begin Play node. I'm going to pull off of this execution pin, and I'm going to let go. And now I have a way of searching. And by the way, there are thousands and thousands of nodes. You absolutely do not need to know them all, and I've never met anybody who does. However, let's start with something that everyone should know. And this one is called a print string node. So we can search for it, print space. Spaces are allowed here. And as soon as I've done that, by the way, this is helpful. it starts to narrow down everything that has the word print in it and the most likely thing that you're looking for. This is true for most searches, by the way, when you're searching for a certain blueprint node, and maybe you only remember a part of what it's called. You could just type that word and start zeroing in on it until you see it, and then you remember. But this is highlighted, print string, and this is the one that I want. In computer programming, a string is just a series of characters, like we use to spell a word. Now, I'm going to do the most typical possible thing that everybody learns the very first time in computer programming, and that is to write a program called Hello World. And that is a string consisting of an uppercase H, lowercase ELLO, and then a comma, and then a space. A space is a character. And then we can type the word world. If you wanted to, you could capitalize that, and I'll put an exclamation point, okay? That is allowed in strings too, okay? So as soon as I start this game, this will occur. On the event of beginning to play, we have asked it to print this to the screen, Hello World. Now, whenever you program something in a blueprint, remember, it is unto itself a file on its own. And also, it is not yet in a form that can directly talk to the microprocessor. We must first compile the blueprint, and that's easy to remember because every blueprint is going to have this compile button up here. And if it has a question mark, that tells you that it has not yet been compiled, and it certainly will not work until you compile it. So you're going to get into the habit of every time you program something, or even if it's already been compiled and you change something, you're going to want to hit compile before attempting to use it. Furthermore, you are going to hit save, this little save icon. And by the way, here's a clue. You can see that there's an asterisk by BP_myTestActor here, and also in the content browser, okay? So compile and save, it's almost like one word, compile and save. Every time you compile, save your progress. And what you want after you've compiled is to see a checkbox that looks like this. Sometimes you will see various other symbols that indicate that there is something wrong with your code and it will need to be fixed before proceeding. So if it's got a checkbox, it's probably not going to create any errors overall when used. Now I will save this and pay attention because this asterisk and this asterisk are going to disappear as soon as I save this blueprint, like so. So let's go back to my main level. And remember, that event was supposed to fire on begin play. So let's begin to play. Click the play button. And I sure don't see it. I don't see it anywhere. But there's a very good reason for that, okay? There's a good reason. And the reason is that this object, this instance of this blueprint class, is not in my world. So the only thing I have to do is put it into my world. I'm not going to see anything. There's no visual representation of that once I go into play. But now, if you pay attention to the upper left corner of your screen here, as soon as I hit play, okay, so I will admit that I had to pause the recording for a moment because there was something that I neglected to do. A moment ago, I was pointing out that despite the fact that our blueprint has the instruction to, on begin play, print this string to the screen, and I pointed out that when I begin play, that is not happening. As you can see, I don't see that anywhere. And then I went on to say, well, of course it wouldn't, because that actor, that object, which is again just a representation of a class, is not yet in our world. If I place it in our world under normal circumstances, you're not going to see this default scene root symbol. That's just for placing things, frankly. And while this actor could certainly have a static mesh associated with it, you would see that part, but this part you wouldn't see. That's just for sort of overall transform information. under normal circumstances, you would now see that message printed right here. Print strings always come up right here on the upper left side of the screen. But when I tried it, I was surprised, and you'll see it's not showing up. And I said to myself, oh no, something must be wrong. So I double-checked my blueprint, and everything looks fine there. So it just occurred to me that there was that bug. I don't know if you remember the bug that was appearing here, and it was annoying that we had to disable all of our screen messages. In order for PrintString to work, we have to re-enable those. So we're going to have to put up with that warning, that meaningless warning for the time being. So let's just do enable all screen messages, like that, spelled the same way and capitalized. And now you can see we've got annoying warnings, and you can see hopefully in Ghosted it tells you how to make those go away again. But so let's take this actor now out of the world once more. We will go into play. Notice that that warning, by the way, does disappear as soon as we go into play. That's a different warning, and we'll talk about how to fix that one on some other day. But I still don't see my print string, and I should. But now you know why, because the actor is not in our world. And it doesn't even matter where this actor is. It can be literally anywhere. And now I should see Hello World. Hello World, okay? It was there for a moment, and if I want that to last longer, I can take my print string node and twirl this arrow down and specify something like a color that I want it to be and how long I want it to be on the screen. So let's put that on the screen for 8 seconds instead of 2 seconds. And let's double click the text color and pick a different color. Maybe I want it to be fully red, not green, and not blue at all. Okay, so just perfectly red. I'll hit OK, and that will last for 8 seconds. Compile. Oh, it's doing an autosave. Usually when it's doing an autosave, it kind of locks you out from being able to do anything else. So we just have to wait this out. And yeah, I'll pause the recording one more time and let this finish, and I'll be right back. Okay, I think I'm recording again, so that's good. And now that I've changed the color and the duration, notice that the compile button has a question mark again because I've made a change. So let's click that and save that. We still have no errors, which is good. And these other errors are things that do not matter to the point that I'm trying to make right now. But if I go into play mode, the actor's in the world, and our print string is going to be in the color we chose, and it's going to last there for 8 seconds instead of 2. Okay, now that texture streaming pool over budget, we're going to talk about on some other day, but I'm just going to fix it right now so that it doesn't annoy us. r.streaming.pool size space. I'm going to just increase this to some ridiculous amount, and hopefully we won't be getting that anymore. Let's go into play, and I just have Hello World. Okay, now what I just typed into that terminal does not matter. We'll cross that bridge when we come to it. I was just trying to make that one extra annoying message disappear. So now we've got just Hello World. And we wrote that program. So let me show you some of the other types of events and what they do as well. Let me get my meeting controls out of the way. Let's go, instead of event begin play, I'm going to disconnect this execution wire. That's what it's called. And that's an output execution pin. This is an input execution pin. I'm going to Alt click on Windows or Option click on Mac to get rid of that. Now this node is called event tick. Event tick will fire out an execution pulse not just when you begin playing. It does when you begin playing, but it does on every subsequent frame as well, forever. So let's set this to something very, very short in duration, maybe like 0.16 seconds. And I'll hook up my event tick to print string. And what we'll see now is Hello World is going to be continuously printed onto the screen for every frame. Compile and save. So let's go back out here and hit play. As soon as it goes into play, Right now, it's just continuing to print it, and it's just not accumulating because probably this interval was not good. So let's leave it on the screen for a second, and that should fill up the whole page. Notice that I hit compile and save on my way out. Good manners. Okay, so every single frame. And the reason that this is unpredictable, how many times that's going to print, is because frame rate is something that varies throughout the game all the time. It sort of depends on the complexity of the screen and the resolution of your texture samples, frankly, how much foliage is in the area, and other things, the complexity of your code, how many lights you have, and so forth. So yeah, that's going to be tied to your frame rate. One thing to know in general about any programs that make use of EventTick, and this is something that you'll find repeated by many instructors of Unreal Engine and other types of programming software, is that use this only when it's absolutely necessary. Because a program can consist of more than just this simple task of printing a text string onto the screen. Some programs involve a lot more things going on, and if I make that happen on every single frame, that is what is known as being computationally expensive. It's hard on your computational resources. If indeed I could make the same thing happen just by calling it on begin play or by some other method. And these are not the only methods by which to call whatever script or code that you're going to have following your first output execution pin. So let me give you another example. We're going to get back to this begin overlap using a different blueprint in just a moment. But in this same blueprint, I think what I'm going to do is go to the viewport and draw your attention to the fact that any blueprint with a viewport will have a panel like this called the Components panel. And notice that this one is basically empty. It just has a reference to itself and the default scene root that we discussed already. But we can add components here. And as we go through this course, you're going to realize that there are many different types of components. The components can be among those things that give distinguishing properties, let's say, to this particular object or blueprint actor. So, with default scene root highlighted, I'll click the Add button. And what I want to add in this case, you're not limited to only these things, by the way. You can search for things, and there are many, many types of components. But let's make a sphere, for example. And all it knows at this point is that it's a static mesh and it's a sphere, and I'll hit compile and save. So this is a component, this static mesh, and we could choose a different static mesh if we wanted to. I would probably rename it if it wasn't a sphere, but as a matter of fact, let's do that. Let's, instead of using a sphere, I'll hit F2 and rename this. I'll call it a cube. But obviously that doesn't look like a cube, so I could go over here into the Details panel and search for one, a cube. Let's use the one that's in Starter Content. Let's see. And yeah, that's in Shapes, Starter Content, and now we've got a cube, okay? So now in the viewport, I can navigate around this just by holding my right mouse button and using the WASD keys and the Q and E to go up and down. And this is also subject to your camera speed if you need to do some detail work. But this has a default material on it, for example, the basic shape material. Let's give it a different material. Let's just search for the word blue, for instance. Oops, I've got to spell it right, blue. And we'll set that as the material instance. Now I'll compile and save. And now, in my world, I don't just have that default scene root. I've got the visual representation of the component that is attached to it. So I'll hit end and we'll snap that to the ground. And this is actually a blueprint, all right? So what we can do is we can actually talk to this blueprint in various ways. So for example, let's suppose that I want to have the ability to do something in my character where I can change the color of that cube every time I hit my left mouse button. Let's say I want to change the color of the cube. Or better yet, let's do something simpler than that. This relates more closely to what we're going to be doing in this lesson anyway. We're going to go back to the cube, and we're going to do a little bit more complex functionality here. Let's select the default scene root once more, and notice that the cube is indented. It's indented relative to the default scene root. I did that on purpose because I wanted the cube to be a child of the scene root. That way, if I happen to translate the scene root, which you can see that's where our gizmo is, the cube is a child of that, and it's going to go along for the ride. Okay? If, on the other hand, I made it a sibling, or if I made that the default scene root, then it wouldn't work. I guess it would if I replaced the default scene root with this cube. But there are certain times that I want components to be attached to other components, and other times when I want them to be not attached. So I'm going to be attaching something again to the default scene root that I do not want to be attached to the cube. And that's going to be something called a box collision. So I'll click Add, and I will type box, and the first thing you're going to see is box collision. Now, right now, before I add that, I want you to see that cube is highlighted. And if I add the box collision, I'll type that again, with cube selected, it will be indented to the cube. So let's just make that box collision bigger. Let me just lock the padlock here. And scale that up sort of uniformly around the cube. Okay, now if I move the cube, remember this box is a child of the cube. And it will, if I select the cube, the box will go along for the ride. And if I were to select the box, if I were to have selected default scene root, then the box would not be a child of the cube. It would be what's called a sibling of the cube. Now, there's a couple of ways that I can still make that happen. I could drag this on top of the default scene root. I could drop it on top of the cube, and you can see now neither one is indented to the other. Or I could delete that box and simply have the default scene root selected rather than the cube, and add that box collision. And now you'll see that it is not indented to the cube, okay? And I can still scale that up, but it's not going to go along for, I scaled the wrong thing. Let's scale up the box collision. It is not necessarily something that is going to go along for the ride if I change the transform of the cube itself. And I'll prove that in just a second because they are siblings. If I now select the cube, it is independent from that box. Okay, and that's kind of what I want. Now, box collisions. Collisions are something that can do more in terms of logic, control, and functionality within a program compared to just being able to prevent somebody from walking through a mesh or something of that nature. So I'm going to continue to scale this with the scaling tool. Not that, the box, I beg your pardon. I'm going to continue to scale the box so that if my character approaches this, that they would have no choice but to occupy this volume that is surrounding the box. They would have no choice. And by doing that, we can make use of a special type of event, which is called an overlap event. So I'm still in my test actor blueprint. And now I can go to the event graph. I no longer need the print string, but I suppose I could leave it there for just a moment, okay? Now, if I do event actor begin overlap, then I can have it set up so that every time my character overlaps, or on the beginning of overlapping that invisible cube, it will trigger this print string. So, if I were to hook up this wire and only this wire, this could work. Let me see if this will even compile. It may not. Okay, but it did. This would probably work, okay? And let me see what will happen if I play the game. I don't want to spawn right in it. Okay. So this may or may not work. Okay, yes, it is working. So every time I begin overlap, I see hello world, and that's just me crossing over that invisible boundary. However, let's suppose I wanted to control that in such a way that that will only happen if the character overlaps that collision volume, but let's say not like a falling leaf or some other character or something of that nature. So we can be more specific than this, and that requires what's known, generally speaking, as blueprint-to-blueprint communication. What we want is to make it so that the only way that this will work is if my third-person character overlaps. Now, we're not going to be using event begin play for this, so I can highlight that and press delete. We're not going to be using event tick for this, so I can highlight that and press delete. This is going to be known as a begin overlap event. Now, if I want to filter for this just to be my BP underscore third person character, which is the name of the default character that I'm playing as, I can prove that. Let's go into its directory, third person, blueprints. Here it is. This is my character. That's Quinn. Okay, so I'm playing as Quinn, and the name of this blueprint is BP underscore third person character. Just like the one we made is called BP underscore my test actor. Your world will eventually be populated by many blueprints that need to be able to communicate with one another. So, in my test actor, I want to find out if it is indeed BP underscore third person character that is overlapping that collision volume. And only if it is, should it be allowed to cause this print string. But if it is not, if it's something else, it should not be able to create this print string. We're going to accomplish this by using a node that will be probably a little bit confusing at first, but will become a lot easier to understand with time. And this is a common concept in just about all types of object-oriented programming. The concept is known as to cast. So when something overlaps that box collision, and that's what this is in regard to, the box collision, this begin overlap. In fact, when I made this, I selected the box, and I right-clicked and chose Add Event. This might have already been in the graph. I think instead, let me just show you from scratch. I'll delete that. With the box, I can right-click, I can add an event, and I can do Add on Component Begin Overlap, and that'll just go anywhere it happens to go in the graph. Likewise, if I don't want to do it that way, I can have that selected in the Components panel, and if I scroll all the way down in the Details panel, I've got that same list of events. So it really doesn't matter. So this is reflective of this. So I want on component begin overlap. But now we want to make sure that it is the third person character and not something else. So we have to cast. This on begin overlap box node has something called the other actor object reference pin. So we need an actor object reference, but an actor, when we make any blueprint at all, if I make any blueprint at all, you'll notice that the parent class of everything underneath it is actor. Now, our player character is an actor, but it's more specific. It's a character class. Character class inherits everything that exists in the pawn class, and the pawn class inherits everything that exists in the base actor class. So the other actor is more of a generic term, but it could be any actor. There are so many actors bound to be in this world that it needs an actor object reference when you're casting, but it has to convert it into this specific instance, this specific character, which inherits from actor. Okay? So that's why we have to cast. The other actor could be any actor. But what I want to do is make sure that it is that one in particular. So I'm going to search for this, cast to BP underscore third person character. And I find the node. You don't have to keep typing once you find it. This is the node I want. If I had another character that had a different name, I would do cast to BP underscore Superman or whatever, okay? Mickey Mouse, whoever the character happens to be. So I will select that, and that connects not only the other actor object reference into the object pin, but now we've cast this, and what we get is a return value that is an object reference, a more specific object reference of the actual character blueprint that we are trying to communicate to. And that's the one that we are playing as in our game. Now, this return value allows me to access information from the third-person character blueprint and also pass along information to the third character blueprint. But for now, what we are going to use it for is to create what's known as a reference. And a reference is a type of variable. Variables are a whole other conversation that we're going to have. But instead of having to cast multiple times every time I need a reference to this object, what I'm going to do is right-click on this, the return value pin, right-click, and choose Promote to Variable. And that will create what's called a variable setter. Okay, now I have set a variable called as BP third person character, which I could even rename if I wanted to. I could go up here, highlight that, and I can call this player character object reference, or anything that I want that makes sense. If I ever need the equivalent of this information anywhere else in this graph, which, by the way, can become very complex, I should not cast again to get this. I should simply drag this variable that we just made into the graph, and I can either get it or I can set it. Okay, and there are different use cases for both examples. But what I can obtain from this variable is exactly what I could obtain from this object pin if I needed to. So anyhow, I don't need this just at the moment. But now this acts sort of like a filter. And now if I connect the output execution pin of this setter to the print string, if the cast succeeds, okay, if I disconnect this pin for a moment, this is what will fire when the cast succeeds. If the cast fails because something has been done incorrectly, you can troubleshoot that by doing a print string. And I can type something in the string myself, such as cast failed. And sometimes casts can fail for a variety of reasons, but it's unlikely that this one will. If this doesn't work, however, we can gain insight into perhaps why it didn't work. If the buck stopped right here, if for some reason your cast isn't working, well, then nothing's going to come out of the true execution pin, and it will never make it over to the rest of the program that you're trying to make happen. Okay, so let's compile that and save that. And let's see what happens. Go into play. Everything's taking a little bit longer because our world is getting more complex and I'm screen recording. So let me step away and overlap that volume again, and hello world appeared. Let's go away again. Hello world appears, and it doesn't matter from which direction, by the way, because we've got a collision volume all around this thing that is supposed to invoke that print string. So I can face this from any direction, and as long as I begin overlapping that invisible box collider, then that essentially that line of code will occur. It will execute. So I'm going to put this back on the ground. I don't like the fact that, oops, I hit delete instead of undo, because I don't like the fact that it's just floating there. So that's fine. And the collider can be underground in this case because it's not paying attention to the ground. It's only paying attention to whether or not the BP third-person character overlapped it. So let's try to trigger this overlap using something that is not the third-person character. So let's go just into the level, and let's bring in something that can act as like a ball, for instance. So I can go to starter content for that, and I'm just going to get that material sphere. There's starter content, shapes, and there's one I like to use. Maybe it's not in starter content. Let's search for it. Material sphere. Okay. And material sphere. Oh, it was in the props directory. Okay, so I'll just put it in the level, raise it up, and it'll just float there if I go into play right now. See that ball is not falling to the ground as you'd expect it to. And the reason is that, of course, it's not simulating physics. So let's just click on it. And in the details panel, choose simulate physics. I could specify a mass for it. In fact, let me make the mass a little bit greater so that it's a little easier for me to control. Let's make it have a mass of 400. And by the way, as soon as I hit play, now that simulate physics is on, it's going to fall to the ground and maybe even bounce. Okay, so there it is back there. Now I'm going to try to make this ball overlap. I got to get on the other side of it. Okay, sorry for the laggy frame rate here. Okay, so let's go and see if I can get that ball without myself to overlap. Oh boy, this frame rate is really hanging right now. All right. So I want to sort of kick it in that direction without walking over that blocking volume myself. Hey, this is a lot harder than it looks, because now it's flowing downhill again. Okay. I'll get on this side of it. Trees are in the way, of course, and the ball has collision. Okay, so I think we're on the right track, except my screen froze up a little bit. And if I keep on nudging it in that direction, as long as I don't get too close, let's see. Yeah, it went all the way into that collision volume, and there was no hello world printed. Okay, so in case you missed it, let me try one more time. Okay, we know that that's a pretty big box collision around there. So let me just nudge it in that direction. Oh. Just trying to avoid having myself bump into it. Yeah. But if I overlap, hello world, okay? That's because we essentially filtered this response by using the cast2 node, okay? So this is sort of like the keymaster. If it's not going to be this third-person character, then it will never, the cast will fail, essentially. And you might want to do nothing if the cast failed, unless you're trying to troubleshoot, in which case you can say print string. But in this case, there was nothing to print because the cast did not fail, because we set it up correctly. So now let's do something a little bit more ambitious. And this is going to pertain to not only this lesson, but to your next lesson also. One thing that occurred to me, and should have occurred to you by now, is that our house, let's get this out of the world. We don't need that anymore. And we don't need this anymore. So we can just simply highlight them either by clicking on them in selection mode, or just by clicking on any actor in the world outliner and pressing delete. So we're back to what we were. As a matter of fact, I think I might increase performance by scaling down my quality a little bit to high. See if that's any better. Yeah, it's that screen recorder. Okay, it is a little smoother frame rate though. Okay. So I'll do this all outside for the time being. I'm going to make another blueprint. And this blueprint is going to be that of a door. So let's go back to clearing our search and finding that folder that I made for blueprints. It's alphabetized, so I'll go in there. The demo blueprint, that can stay, but let's make another folder, new folder, and I'll call it doors. And then in here, I might have many types of doors. So in here, I'll make another subfolder called door_01. Okay, because I might want to have different looking doors and maybe be decorated differently or serve different purposes. Maybe there's going to be a sliding door, for example, but this is going to be a traditional door. So we'll open this up and I'm going to right click once again and I'm going to make a new blueprint class. When you're choosing your class, you have to understand when it is necessary to use anything that is later in the hierarchy that inherits from actor. And you can read these. And by the way, you can disclose other classes and subclasses, etc. if you're just curious and just have a look at them. These just happen to be the most common classes. Everything in this list is an actor, but a scene component inherits from an actor component, and an actor component inherits from a game mode base, and all of them inherit from a player controller. A player controller inherits from character. All of them inherit from actor, okay? And for this case, we only need an actor. And again, I'll call this one BP_door_01. And we're going to build up this blueprint so that we have a door that automatically opens when we walk up to it and automatically closes when we walk away from it. So let's get right into that. I double-clicked the blueprint, and it was kind enough to dock itself, but if it didn't, you can just grab the tab and dock it up there. I'm going to select the default scene route first, and I'm going to click Add, and I'm just going to choose Static Mesh. And I'll rename this while I have the opportunity, Door Frame. And nothing appears in the viewport yet because I haven't selected which static mesh I want to use. Now I should point out that in starter content, under props probably, we have many things. We have a door frame right here, and we have a door also. So let's start by using these. We can get better door frames and better doors from Quixel Bridge and the marketplace and frankly some of the asset packs that I have bundled up in this level. But let's just do it with these basic props that you have access to instantaneously. You could even do this in a separate level or a separate project just for practice. So I'll select the door frame, and then when I go back to this blueprint, remember it's still selected in my content browser, still highlighted. So I can use that same trick when I'm choosing the static mesh for this door frame. In the Details panel, I can use Selected Asset from Content Browser and just pop it in there. Okay, and by the way, we have this legend on the bottom so we can see the x-axis, the y-axis, and the z-axis with that color code and that little legend. And that can be useful, okay, to know what directions things are facing. So I'm going to look at it from this perspective. Now I want another mesh here, and that's going to be the door itself. So I'm going to, this time I do want to make it a child of the door frame. So I'll leave door frame highlighted and add another static mesh. But before I do that, let me show you another trick. If I select the door and then go back to the blueprint and add static mesh, it's going to remember what I have selected. So look, static mesh SM_door, and there it is. Now, the first thing I notice is that it's not positioned correctly. So what I want to do is I want to use my gizmos, my translation tools, and if necessary, adjust their snapping values. Let me hit undo. I think that was set too small. So let's set that to 5 and see how well centered that can be. That looks pretty good. I want to look at it from the side as well because you're going to be able to kind of see this from both sides. And I want it to be about in the middle. And it looks like it is about in the middle. Notice, though, that the pivot point on this door is not in the center, as it is for many types of meshes. Now, there are ways to relocate the pivot points on any mesh, but in this case, we want this one to be where it's located on the lower left corner of the door, because if I apply rotation, the door will swing on that pivot point in either direction, okay? So if the pivot point were, let's say, somewhere in the middle and I were to rotate it, effectively the door would just spin. So it's good that the fact that the pivot is located where it is important in this case for the door to rotate instead of spin or do something else that's very, very unpredictable. So let's make this happen also with an overlap. Now, I don't want the box collision to be a child of the door, because when the door opens, that box would go along for the ride. I do not want that. I want it to be a child of the frame. So I'll select the frame first. That way, when the door opens, it's not going to move the collision box. The collision box is going to stay put relative to the door frame. So I've got that highlighted, and I'm going to add a box collision, just like we did before. And I want to scale this so that our player has no choice but to overlap this. But I want this to be pretty forgiving, okay? And the reason that it needs to be forgiving is because if the character has to get too close in order to cause that door to open, the door might in fact open and collide with the character, which would stop it from opening, right? So we want to make sure that this is nicely around there, and it looks like it is. Might be a little bit too generous on the sides. Let's try to make this symmetrical. Just look at it from the front angle, and it does look pretty symmetrical. Okay, so let's compile and save. And I have not written the code yet, but we can still put this blueprint into our level. So we'll go back to the content browser, into our blueprints folder, and find our doors. Here's door 01, and let's just put that right there, for example. I want to show you, first of all, that this is our blueprint actor. This is an object, and it is of a specific class. It is of type actor. And it has components inside of it. One of the components is a default scene root. Another component is a static mesh that represents the frame of the door. And then another component is the door mesh itself. And then finally, the last component is a box collision. If I go into play right now, I want to show you a problem. And this might remind you of something. I should not be able to, in order to get through that door, I should have to open it and then walk through it while it's open. But I should not be able to do this. And that's just a gentle reminder that not everything that we get when it comes in necessarily has collision. And I happened to recall that the starter content door mesh doesn't have collision. So let's get back to that mesh and add some collision to it. This is something we've done before, but I'll take this opportunity to remind you how to do something like this. So we're going to go back into props, find the SM_door. This is a static mesh. Double click it to open it. This is the static mesh editor, and there's no collision. So I'm going to open the collision menu, and I'm going to add a box simplified collision. And that, you can see, just puts like a little collision hull around there. Very, very simple. Not a zillion triangles, because it doesn't need to be. It just has to stop us from walking through that mesh. And if I simply save the mesh that way, then if I go back into play, and I apologize for that lag, I can no longer walk through the door. Okay, so that's the first thing that we had to take care of. Walking through the door makes this sort of thing kind of pointless. So let's go back now, and I'm going to start moving a little bit quickly. Okay, this is the mesh editor. I can close that. Here is what we've got so far, and it just consists of 2 static mesh components, a box collision, and a default scene root in case I want to put it in different locations. Okay, but it does have this box collision. So let's go to the event graph and do something like what we did before. I can delete the courtesy nodes because I don't need them. I'll highlight the box and either scroll all the way down and choose on component begin overlap, or I can just right click it here, which I personally find easier. Add on component begin overlap. Now I want it to only fire this code again if it is the character walking up to the door. I don't want that beach ball getting close to the door and having the door open. I only want it to happen if I walk up to it. So again, I'm going to cast to from the other actor pin. Right now, it only knows that some other actor is going to overlap this, but it doesn't know the specific instance of that class BP underscore third person character. So we have to cast it. So we'll pull off this pin, search for cast to space BP underscore until we find third person character, or whatever your character's name happens to be after you get into creating your own characters, which we'll be doing very soon. Promote this to a variable by right-clicking, promote to variable. You could rename it if you want to. You can always hit F2 and rename it. Player, character, object, reference, like so. And now if I ever need this elsewhere in my graph, and we will in a moment, I can just drag it in and use get. Okay, so let's delete that for the time being. So now I've got my player character. And ultimately what I want to do is determined by a node called set relative, not location, but rotation. Set relative, I misspelled it, that's why we don't see it. Set relative rotation. Now, it already knows what components are in this blueprint. What do I want to set the relative rotation of? Well, it's going to be this static mesh, the door. So I can pull that in, and it automatically connects this component to it. If I were to just get this node in a disembodied way, notice that it has a target and needs to know what is it rotating. So we would have to pull that component out of our components panel and connect that to the target pin so it knows what we want to be rotated. So let's get these together and just move them over a little bit. Let me just point something out to you. Rotation is an example of something called a vector. And one of these days we're going to have just a lesson on what vectors are. But a vector is usually comprised of 3 values, if it's a vector 3 that is, which is a coordinate system. For rotation, we're thinking about it rotating on the x-axis, y-axis, and z-axis. But let's suppose I use the node set relative location or set relative scale. Set relative scale. Or something like set color. This is all wrapped up in what's called a struct. But you can see this is also a vector, RGB. RGB is like XYZ. So if I have something that exists in 3D space, that has a location. It could be graphed on the x-axis and the y-axis and the z. The x-axis is the forward axis, the y is perpendicular to that, and the z is the up-down axis. Okay, so for things like colors and locations and scales and rotations, those are vector 3. We call them vector 3 types of variables. Okay, so if I want the door to rotate, on which of these 3 axes do you think it needs to rotate? Now, if you guessed x, well, that's incorrect because it would basically look like it was spinning in front of you, because the x-axis points forward. If you wanted to rotate it on the y-axis, it would also look like it's spinning, but towards you and away from you, I guess is the best way that I could put it. But you want to think of the z-axis, especially for rotation, as like a line that goes through the world origin pointing straight up and straight down for infinity. So the z-axis is what something will spin around. And that is relative to the pivot point, which happens to be in the correct place on our door mesh. So if I select the door mesh, remember the pivot point is there. And the z-axis is, if you can see the color, is what's pointing up. So I want it to pivot along that z-axis. So let's do this the wrong way first. Okay, I'll go back into the event graph, and let's just say I want the door to open 120 degrees. I could type, this is called hard coding, 120 into the Z field, and I could just, don't want to cover that up. I could just simply connect the execution pin, like so. Now, when I do this, the door is going to rotate open, but I wonder if any of you can predict what undesirable behavior this is going to exhibit. It will open. I promise you that. Okay, so let's walk up to the door. I'll go into play mode. Let's walk into that collision volume. And the door snaps open. And I would prefer for it to open away from me, by the way. So to do that, you could just rotate the entire blueprint 180 degrees. But still, it's the same problem. It's opening all at once. Boop. So it is effectively working, but it's not working over a period of time, which is what we would like. So in order to make this work the way we want, I'm going to make room for something else here. And it is called a timeline. So we'll pull off, well, let's just disconnect, Alt-click. We'll disconnect these two from the time being, pull off of this execution pin, and we're going to search for Add Timeline. A timeline allows you to create tracks inside of it that have durations that can be specified by yourself and even curves in them that you can create yourself. So I'm going to name this door transition time, just so that somebody else could read my code and know what it is for. And the neat thing about a timeline is that you can double click and get inside of it. What I need to start by doing is to create a track. And there are different kinds of tracks that you can have, but I want to create, in this case, what's called a float track. And a float is just any number that can have a decimal after it. So I can have, let's say, an integer like 4. That's an integer. But a float would be something like 4.1279836. You get the idea. Things that have to be more fine-grained tend to work with float values. So I can name the track if I want as well. Door, let's see. Oh, it's auto-saving. Let me pause for 1 second. Yeah, that's why I couldn't type, because it was auto-saving. But right here, if I wanted to, I could right-click. This one, it doesn't use F2. You have to right-click it. And I can just call it door curve or whatever makes sense. You don't even have to rename that necessarily. Now, in this area, I'm going to specify over what duration do I want this to take place, this timeline. Do I want it to be 5 seconds? That sounds a little bit lengthy to me for a door. Maybe if it was like a horror film and the door was creaking open slowly, might do something like 10 seconds. But I think for today's purpose, we'll do a 3-second float track. Make sure when you highlight that it's fully highlighted, because sometimes there's a way of clicking there that makes it look sort of highlighted, but you want it to be fully highlighted like that, and then press Enter once you've chosen your value. Now you're going to hit these two buttons, and that's just going to bring this all into view. So it starts at 0 and ends at exactly 3 seconds. Somewhere near the beginning of this line, I would like for you to right-click and use this option, Add Key to Curve Float 0, and that's called a keyframe. But you'll notice, let me move my meeting controls, you'll notice that I can enter values here for the time and the value. I want to round the time off to exactly 0 and press Enter so that I know that that's the beginning of the timeline, and I want the value to also be 0. And now I want to do something similar near the end of the timeline. Right-click, add a key, round off the time to exactly 3 seconds. Remember, that's the maximum duration of this timeline, 3 seconds. And I want to make the value 1, like so. And we can just bring this all into view again by hitting both of these buttons. Now, this is called a linear curve, it's almost funny to even call it a curve. But if I wanted to have like an ease in, ease out, more natural type of movement, you could make it cubic. So if I right-click, it doesn't matter either one of these keys. If I right-click it, you get different options. Let me move my meeting controls again. You get different options. You can make your own custom curve if you want to. But if you do this one, auto, okay, you get cubic interpolation with automatic tangents, and you'll see it's got an ease in and an ease out. And this should be fine. So while I've made some progress, I am going to compile and save. And I do not want to exit out of the blueprint. I just want to exit out of this tab, which is the inside of our timeline. And you'll see what that does. It takes us back to our event graph. So again, if I double click, I'm inside the timeline and it's tabbed. I have to close that to get back to where I was. Now what the return value is a float single precision. Why is it a float? Because that's the type of track we made, and it's going from 0 to 1 over a period of 3 seconds with easing in and easing out, okay? So let's close that. And now what I have to do is I have to apply that. This is not going to work if I try to connect it to set the full rotation. I have to gain access to only the z axis. And anytime you have a normal vector, the members that make up that vector individually are floats. The vector is usually wrapped up into something called a structure, or struct for short. A struct is basically just a collection of variables. In this case, there are 3. A float value for x, a float value for y, and a float value for z. So if I click split struct pin, I now have access to each axis of that struct. And the only one that needs anything is our z-axis. That is going to be the axis upon which our door is going to rotate. Now, this is not going to work. I'm going to tell you right now it's not going to work, and I'll show you why. First of all, let's compile and save. We don't have any errors in our blueprint, but if I attempt to walk through the door, it's still not going to work. Or it's not going to work. It's not going to work as far as we can tell. It's working, but it's rotating only 1 degree over 3 seconds. So that's practically, if not literally, invisible. So remember, inside of our timeline, let's go back to the door. Inside of our timeline, it only transitioned from 0 to 1, but I want to rotate this by 120 degrees over that duration. We can do that using a lerp, just like what we used in materials, a linear interpolate. So I can right-click and type lerp, and it will find that for me. We want the float variety, float, because this is a float value, and this expects a float value. So we want to lerp a float value, and our timeline is going to be what drives the alpha. So this is going to change from 0 to the number of degrees that I want to rotate the door, which is 120. Okay, and I can hard code that just by typing it in there. Now I'm going to replace this connection with the output of our linear interpolate. Okay, so we'll compile and save, and we'll see if this is indeed working. That's working perfectly. So now, if I walk through the door, which I can, or if I decide to, if I decide to back away after it opens, we would like to have it close behind us. So we can script that as well in the same blueprint. So here we are back where we left off. Okay, so just to review, we used the box to generate an event, and that event was on component begin overlap. You can see boxes in parentheses because I obtained that event by right-clicking here, or again by scrolling down to the bottom of the details panel. Okay, so it's the box collision that is being overlapped, but by what? Some other actor. but we want to filter it so that it will only respond to our BP third-person character class. So we take in the generic object reference and we convert it to a specific reference to a class that is in our world, which, by the way, is one reason that a cast can fail. Sometimes if an actor is not yet in your world and you're trying to cast to it, that will cause a cast to fail. It has to be loaded into memory while you are in gameplay mode. In other words, spawned already into your world before a cast will be able to succeed. But remember, when we start the game, we're not already in a location that overlaps with that collision volume. So I know that by the time we get to the point of overlapping the box collision, that our character is for sure in the world. So there's no reason that this cast should fail. Okay, so let's back up a little bit, and now that I've got that object reference, we set it as a variable in case I need this later, and I'm about to. So I'm going to drag this into our graph, release, and I'm going to use get player character object reference. We're going to be using that because the information from this pin is identical to the information that I can obtain from this pin. So now we are going to use that same box collision to trigger the door closing. So we'll select the box, right-click. Now I can add the event from here, but just for variety, we'll select it here. Go down to the bottom of our details panel while the box component is selected, and we're going to use this event, onComponentEnd overlap, and that gives us this event. That's very much like onComponentBegin overlap, but it's just the opposite, onComponentEnd overlap. We'll just organize it like that. Now, we want to make sure that it is when the player character overlaps on the way out. And we could technically do that by casting again. But casting is a relatively computationally expensive process. And we already have the reference to our player character. So we don't need to cast again. It's very bad practice to cast more than once to the same other Blueprint class when we have already stored that variable. So now I want to make this conditional. If you have some background in computer programming, you might be familiar with what are called if statements. So it is, if something is true, you do this. If something is not true, you either do nothing or something else. So we want to check to make sure that it is indeed this player character that is overlapping the box on the way out. So here's what we're going to do. Instead of casting again, we're going to pull off our other actor pin, and I'm going to use a node called an equal Boolean. Boolean is a data type in programming that can be one of two values. It can be a 0 or a 1, or in other words, true or false, only two possible states. To get the equal Boolean, it's very, very useful to know the shortcut. You just hit the equal sign twice in a row on your keyboard. So I'll press equal, 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 equal. And you'll find it under operators, equal. That's an equal Boolean. So if the other actor is equal to this object reference, okay, this class reference right here, then we get the value of that Boolean here, which can be true or false. So the if statement in Blueprint is called a branch node. So I'll just search for branch. Got to spell it correctly. And even with BRA, I get flow control branch. Even by just typing BRA, immediately it found branch. I'm pretty sure that the shortcut for that is just to hold down B and left click, because it's something that you're going to need so often. It's worth memorizing. And you can also tell by the colors of these data pins that this node is expecting a Boolean data type. If you hover over it, it will even tell you so. But the pins are color-coded so that you can know what type of data is being expected or being provided by any other given node. I can tell that that's a Boolean, or I should say that most people can tell that that's a Boolean by looking at its color. Color codes and I don't get along very well just because I have poor color vision. But nevertheless, I know from experience this is a Boolean, and this takes in a Boolean. So I'm going to connect this execution pin, and when our character leaves that collision volume, it's checking, is the other actor that is overlapping that collision volume, is it the same as our player character, which we stored as a variable? This is why we don't have to cast again. We've stored that as a variable. And if it is, something will come out of the true pin, an execution pulse. But if it is not, we'll get an execution pulse out of the false pin. So in this case, I know it is true, so I can connect this to reverse, like so. If I compile and save, then this is where the magic happens. Walk up to it. The door opens. We walk away from it. The door closes. I can walk through it. Of course, I want to wait for it to open, and then it will close behind me. If I walk up to it from this direction, it will also open, but it's going to open toward me because that's how we did the rotation, but still, it will work in either direction and close behind me that way. Let me hit escape for a moment, and we're going to take this entire door blueprint and rotate it 180 degrees. And we can now work with this just like any other actor in our scene. This just happens to be a blueprint actor, unlike, let's say, just a plain static mesh actor. This is a blueprint actor. And now I'm going to translate it and perhaps also scale it if necessary into this opening on the static mesh that is meant for a door. Okay, I want that snapped to the surface underneath, so I'll hit end. Yeah, and for some reason, I guess its origin is not the bottom of the mesh, but that's okay. So we can adjust that microscopically if it turns out that we need to. Definitely my camera is going too fast, so let me slow that down. I'm using my scroll wheel, by the way, once again to do that. And I want to just get this right into that space as accurately as I can. And it's not going to be perfect, as you can see, at first. That's okay, because we can scale this and translate it. Excuse me, I accidentally clicked off it there. We can scale this just like any other actor. And I want to center it first so that it is the same distance away from both sides before I start scaling it. So we're going to reduce the snapping size for scaling to a smaller value. I'll select my blueprint again, scale it out a little bit, and maybe I will reduce my translation grid snapping size. And we just have to make sure that the inner mesh, which is the door, is not colliding with anything, such as this static mesh that's next to it. So I'm going to sink this into that space, and I want to make sure that it is about the same distance in as it is out. This might be easier to assess once we scale this up. So it definitely needs to be taller. Now that's too tall, so let's go ahead and reduce our scaling snap size even more. That's still too much. I might have to freehand this, we'll see. All right, I want to just also double check for any leaks. I can see that there's a little tiny leak on that side, little tiny leak just on the right. So let's scale it in that direction and maybe translate it just over to the right a tiny little bit, searching for leaks. Leaks can, by the way, lead to lighting problems. Okay, so this looks pretty well centered to me. I can see the translation tool even if I look at this from the side. Okay, so now if I go back into play, oh, that time I might have spawned inside the collision volume. All right, so let me have this stabilize for a second. I might have to restart my computer because it's getting real jittery. But if I walk up to the door, now it opens and I can enter my lovely home. Yeah, we'll address those flashy lights later. and the door closes behind me. And if I want to leave, I just want to make sure that I don't get so close to the door that it bumps into me, because it's only opening one direction. And it's opening in that direction simply because I rotated it 180 degrees, if you recall, before I placed it. If I decide I wanted to open the other way, I could just rotate that whole blueprint 180 degrees again. It should open toward me. I can now enter the house, and when I end overlap, it'll close behind me. So we have a perfectly working blueprint. Now, another advantage to using blueprint actors such as this door is that they are reusable. I can have multiple instances of this throughout my building. So I'll show you an example of doing exactly that. Speed up my camera a little bit. I know that I've got that opening over here, for example, to get into the garage, which we haven't really truly lit yet. But let me get a copy of this door. Now, I could either just, use the translation tool and select the door, and if I Alt drag, I can get a copy of it, like so. And just sort of like a dollhouse, I can just place it exactly where it's needed. I know it's going to be rotated 90 degrees in this direction. If I want to translate it towards where the garage door is, I can hold down Shift. And as I do that, it takes the camera with it. And that's a very, very handy tool as well. Now I can place this just as it's needed into this space. And even if I have to rescale it or anything, this instance is going to work just as well as our front door, and also can be rotated if necessary. All right, so I'll leave that there. Let's go back into play mode one more time and see how it goes. Okay, so this time I think what I'll do is I'll go into the garage. Maybe that would be better if it were rotated by 180 degrees. This is just being lit by emissive materials right now. I don't think there's anything else in here. So I can get back into the house. The same way. I can see that I can translate that better. But it'll close behind me. And this is just another instance, again, of the exact same blueprint. So go back into the garage. And now you might have a little bit of insight, even though it's slightly more complex, into what's happening here. When the garage opens, I am overlapping a box collision, and that logic for it to open has been basically scripted inside of a blueprint. So I can now run back this way, and I can enter the house through the front door if I want to, and make them open whichever direction I want. Okay? So with that, I will leave you, and I sure hope that you will try this in your very own projects. And if you have any trouble, don't hesitate to reach out to me. Thank you so much, and I'll see you next time. Bye-bye.